unlike the, what was the last proof we just completed? What type of proof is that? Deduction. And it's also known as what? Direct proof. Now in direct proof, we go in one direction. If A happens, then B must happen, right? Then you start from A, it implies something, and this also means something, and this also means something, and of course, you go on like that, and something means B. Then you know that, oh, if you start with this, you're going to get that, right? So definitely it's a unidirectional proof, if I can put it that way, like one direction. You just go from left to right, basically. Okay? In proof by equivalent is a, should I say bi-directional? I don't know. Two-directional process. So it means if A and B are equivalent, then if A happens, B must happen. If B happens, A also must happen. That's the proof by equivalence. If A is equivalent to B, if A and B are equivalent, let me put it that way, then A implies B and B implies A. Okay? But rather than prove the first side and prove the second side, we can actually prove both of them together using the symbol of this symbol, equivalent to. It means biconditional. We call this biconditional. Biconditional means this happen, if this happens, this will happen, and if this happens, this will happen. It means both are equivalent. So we can always work the solution line by line, connecting each step with this. Okay, we'll do one or two examples now. So that's the difference between the proof by deduction and the proof by equivalence. So in deduction, it's a one-directional process. In proof by equivalence, it's a two-directional process. Okay, and rather than prove the first direction, then go back again to prove the second direction, you can always use some mathematics operation that will maintain that equivalence each step of the way. Some of the things you will have to include, like maybe adding something to both sides, it could be subtracting something from both sides. Okay, I'll give you an example. A equals B. A plus C equals B plus C. Does this imply this? Yes? Now, that is one direction, right? I can also say from A plus C equals B plus C, it implies A is equal to B. Is that true? So you could see that I went this direction, then I went the other way as well. But rather than writing this first and then this one, we can say A equals B, if and only if A plus C equals B plus C. So in this case, you don't have to work the first one, then go back to the second one. With this, you have combined this together. But that makes sense because you can add to both sides when you are proving by equivalence. You can do things to both sides. You can multiply to both sides. You can divide, of course, some division. Not everything can be divided. Do you understand my point? So this is how we do proof by equivalence. So I'm just going to write a short, maybe note. Please, quickly. Forget the keyword, equivalent. So it's both ways. So two things that we need to do is either you have to both sides, subtract from both sides, multiply and divide, of course, non-zero, and you have to avoid square roots and square. And I'll tell you why that has to be avoided. Okay? So log of positive numbers. Yeah. So those are the three key things. I'm trying to give you a scenario of this one. A squared equals to B squared being equivalent to A equals plus or minus b. That is, if a squared is equal to b squared, then a is equal to plus or minus b. And if a is equal to plus or minus b, then a squared must be equal to b squared. This is what we should have. However, if you actually just do a squared is equal to b squared, and you decide to take the square root of both sides, you might end up getting either a is equal to b. Square root might give you a is equal to b. Of course, you can also get a minus b. But then, this could also be plus or minus, any of them. There will be some kind of confusion that you don't even know. Oh, maybe I should do plus or minus on the left, plus or minus on the right. All this kind of confusion, which will, maybe for your level, by actually. Rather than doing that, if you have done maybe this equals to 0, of course you know this will be a plus b and a minus b equals to 0, yes? And that would be very clear that from here a is negative b and from here a is positive b. Do you understand what I'm saying? So rather than do square roots and sometimes forgetting to do plus or minus, and you don't even know if you have to do plus or minus on which of them, or would you rather just say plus or minus a is equal to plus or minus b? Do you understand my point? So if you can avoid this kind of situation, it will be better. Okay? So square and square root would not be advisable, especially the square root. Especially the square root. Okay? Look at the case of inequality. Minus 3, is minus 3 less than 1? Yes? If you square both sides now, what do you notice? 9 is less than 1. You see the kind of nonsense it produces. So you want, if you are trying to do an equivalence of this compared to something else, then you run into some errors. So if you can avoid those kind of situations, if possible, it will be nice when dealing with equivalent problem. Okay, everyone? Alright, so, but doing normal arithmetic operations like add, subtract, multiply, and divide, of course your divide cannot be including 0. You cannot divide by 0. Alright? And using logarithm of positive numbers, of course, then you can still get your equivalent problems done. So let's quickly see some problems from the book. Some of the exercises that we have here, they are classified under equivalence, but I don't see them as equivalent problems. But they can be done in other ways. So I'll just go to the one that sound like equivalence. Let's see. Question, do you have your textbook with you? Maybe not, okay. I'll do, let me see which one is. Okay, I'll start with the first one then I ask you to try the second one. And maybe we can look at one or two. This is not a long topic actually, so we should be fine. So let's see, this is from exercise 5C of your textbook, problems. So I put where we can get it, exercise 5C, 9C, sorry, page 218. So in case you want to practice more, go to that exercise. There are so many questions there. Let's see, okay, one of them is this. Find the smallest Charlie, this doesn't look like, but it's all right. Find the smallest positive integer a such that, well, that's not the exact language in the book, but that's okay. Such that this x plus 2a is equal to 0 as real roots. After this, we will do, okay, maybe we'll do that first. Okay, let's do this together. Everybody pay attention. Find the smallest positive integer a such that that quadratic equation has real roots. When does a quadratic equation have real roots? Does anybody know? Quadratic equation, real roots. Does anybody know? Greater than or equal to 0. Real roots. The real roots could be equal, could be distinct. We don't care, but as long as they are real. It means when it is not complex. When it is complex, it's when your b squared minus 4ac is less than 0. So if you are removing the less than, now there are three possibilities. Your b squared minus 4ac will be greater than 0, equal to 0, or less than 0, right? Right? This is the only case of complex, so these two are real. But the so-called real can either be distinct or equal. Distinct is when they are the same. When they are different, sorry. Then equal means when they are the same. Does it make sense? So these two are the real. Now what do we call this b squared minus 4ac? What's the word for it? Discriminants. Discriminants. Okay? Now, English was my problem back in the days, learning some of this chemistry stuff and whatever. So I tried to connect it to a real life situation. Discriminants sound like discrimination, isn't it? You're being biased, right? So you are the one trying to be biased to the roots, basically. That, oh, you guys are the complex one. If we don't tell the difference between ourselves, then we don't discriminate, basically. So you're trying to classify them into, oh, the groups that are complex. Oh, these are identical twins. Do you understand? Oh, these are real brothers. We can see them. They are not like I, that are imaginary. Do you understand? So then in your, for those of you, how many of you remember b squared minus 4ac, or you don't know what this means, or you don't understand the response I was given? Who doesn't understand this b squared minus 4ac that somebody mentioned just now? Everybody understands it. All right, good. And you know how we got this, right? Talk to me, please. Yes. Okay, great. Now, we call it discriminants. So basically, we'll solve this problem by considering discriminants. Have a question? Ask me. Particularly when I'm talking. Don't try to talk to someone. Find the smallest positive value for which this as that. So I would say it just goes through to discriminants. So this will happen, this equation, I would say, this equation x squared plus a squared minus 3 x plus 2a equals 0 has real roots if and only if, can you see that? How the equivalence came about now. If and only if the discriminant is greater than 0, right? Or greater than or equal to 0. If and only if discriminant is greater than or equal to 0. Do you get my point? So if the discriminant is greater than 0, this statement is true. Okay? If this statement is true, the discriminant is greater than 0. That is where the equivalence comes in. Does that make sense? And this happens, of course, if and only if, what is our b squared minus 4ac? B squared is what? A minus 3 squared, right? Yes. Minus 4ac, 4, 1, 2a, greater than or equal to 0. Does this make sense? Leo? So, you just proceed with the calculation. This will be a squared minus 6a plus 9, and this will be minus 8a. Are we making sense? What does that become? Is that minus 14? If we have 14, what are the factors of 9 that gives that? Greater than 2? 7 and 2. Yes, that's it. So this happens. A squared minus 14a plus 9 is greater than or equal to 0. Okay, then we factorize. So I'm only saying the first is equivalent to my process, right? So this will be minus 2, minus 7, right? Hello? Now, this is product of two numbers. It's positive. When do you have product of two numbers to be positive? It's either, talk to me. When do you have product of two numbers to be positive? What are the possibilities? Speak louder.
Even and even.
No, that's not to do with even. What? I can't hear you. Can I hear what you are saying? Who's speaking? Positive, positive, negative, negative. Is it that both are positive or both are negative, right? So we have option. Yes.
Wouldn't that be a squared minus 9
Oh,
plus
Lillian, why did you give me that?
That's why I said wait.
You said two.
I rewrote it.
Okay, so that's wrong. Okay, so what happens when we have a squared minus 14a plus 9 to be greater than 0? It's not even factorizable, so we have to use. No. We're completing the square would be better. Completing the square would be better. In this case, if you use formula, it's not like it's equal to. Okay, if you use the formula, you get two values. Would you say the two values are greater than 0? Do you get the point? If you use the formula, let's say, I'm trying to tell you why the formula doesn't make sense. So if you have like minus 5a plus 6 greater than or equal to 0, something like that, and you claim to use the formula, so how do you write it? A equals, or do you want to say A greater? Remember, the formula would be A is equal to, if this was x now, x is equal to minus b, right? Plus or minus root over 2a. So if you use the formula for this, would you say x is greater or equal to? Are you going to just change it to greater than? Leo, if you need to walk around, you should. Do you understand my point? So the best thing is to use completing the square. Does everybody know how to use completing the square? So this is equivalent to a squared minus 14a. You will need to add half square of this, and of course you subtract it immediately, so it looks like you haven't changed anything. Knowing fully well that this is a perfect square. Half of this squared, that's what you had, and subtract. Now, the first 3 gives you this. Okay? And this will begin to be actually minus 49 plus 9. Minus is this is plus 49. Can you see that? Greater than or equal to 0. So you have a minus 7 to be greater than or equal to what? Now, if you square a minus 7, if you square a number and it's greater than 40, that number could either be, now I'm going to use inequality now. Even though I've advised not to use, what's it called? Square roots as much as possible, but I'm trying to manipulate it another way now. Do you remember this?
Yes.
We did something like this the last time. We tried to avoid committing blunder by invoking absolute value. Do you remember that? So I'm using the same technique. So if I square absolute value of something, it's either I square the number or I square its negative. Do you agree? If I square an absolute value, it's either I square the number the way it is or I have squared the negative. Either way, I'm claiming it's greater than 40. Do you understand how I use that square now? Hello, talk to me.
Yes.
Are you lost? Confusing? No. Sleepy? You should walk around. So, there are two possibilities this will give me. One is that a minus 7 will be greater than square root of 40. The other is that negation of a minus 7 is greater than or equal to 40. So it's either of these cases. Do you understand? So from here, a is greater than or equal to 7 plus that. But here, a minus 7 is actually less than or equal to this. Yes? Which means a is less than or equal to 7 minus that. Calculator, please. Check each of them. And these two will imply, what is this? What is this? And this should be 0 point something. Square root of 40 will be 6 something, 13 point something.
18.32.
And this is,
0.68.
can we see that? Now it says the smallest positive. What is this value in question? What is that smallest positive? What? Speak louder.
Wait, one.
You sure?
It says
Yeah, smallest positive integer. So what is that A? It doesn't make sense. How? Everybody quiet. I'm interested in that. Why do you think it doesn't make sense? Because there's nothing. It said or, not both.
Oh, yeah.
What again? Why are you not considering this? So, 0 is not positive. Did you hear that? So there are two options. Is it that the so-called A is more than 13.23 or equal to it, which is not an integer, so 14 comes in this category. Or the A is less than or equal to 0.68, which means the only positive that satisfies, the only integer that satisfies this is what? 0. But it says positive integer, not just an integer. So nothing comes out of this. This is the only possibility. Does that make sense? Questions? Let's write this quickly. Okay. Yes?
A squared minus b squared. Can we use the double, like, you know that
Equivalence?
Yeah.
Yeah.
The one on.
Yeah, so if you are using this technique, yes. Oh yeah, that's what it should have been. Yes, that's what it should have been. The next question we will do together. I will need your contribution. And after that,